Okay, here again in Packet Tracer subnetting scenario. These are the topology, same as this. Addressing table, we fill this later. Objectives. Part 1. Design an IP addressing scheme. Part 2. Design IP addresses to network devices and verify connectivity. Scenario. In this activity, you are given the network address of 192.168.100.0/24 to subnet and provide the IP address for the network shown in the topology. Each LAN in the network requires enough space for at least 25 addresses for end devices, the switch, and the router. The connection between R1 to R2 will require an IP address for each another link. Part 1. Design an IP address scheme. Step 1. Subnet the 192.168.100.0/24 network into the appropriate number of subnets. So, A. Based on the topology, how many subnets are needed? So basically, we decided how many subnets are we needed based on the network that connect. We have PC1 connected to switch 1, PC2, switch 2, PC3, switch 3, PC4, switch 4, router 1, router 2. So basically, we have 5 network are connect. So we have to make 5 subnets. Okay. B. How many bits must be borrowed to support the number of subnets in the topology table? So bits. Here's the formula of the bits. So 2 to the power of n bits means subnets. If we try to fill 2 to the power of 2 bits means 4 subnets. So 4 is not enough for filling the 5 subnets. We try 2 to the power of 3 bits equals 8 subnets. So 3 bits is enough to fill 5 subnets. So the answer is 3 bits. How many subnets does this create? When we borrow 3 bits, obviously we will get 2 to the power of 3. That means 8 subnet. So as I say before in the formula here, if we borrowed 3 bits, then we got 8 subnets. So 8 subnets. Sorry. 8 subnets. And how many usable hosts does this create per subnet? So when we borrow 3 bits and get 8 subnet, we usually get 32 address. 1 network address and broadcast address are available. So we have 30 usable IP address. So we have 30 usable IP address. Okay. 8 subnets. Note, if your answer is less than the 25 hosts required, then you borrow too many bits. Yeah, so we got the correct borrow. We produce 30 usable IP address. Okay, and E calculate the binary value for the first 5 subnets. The first subnet is already shown. Okay, the subnets. So because it's 3 bits, so we filled in the 3 columns here. So here is 0, 0 1 0 0 sorry 0 0 0 0 0 and 0 1 0 0 0 0 0 0 and 0 1 1 0 0 0 0 0 and 1 0 0 0 0 0 0 and 0. Yeah. So calculate the binary and decimal value of the new subnet mask. So the 3 bits. Remember the 3 bits. So we fill 1, 1, and 1, and the rest of them is 0, 0, 0, and 0. Here's the subnet masks are 224 subnet masks. G. Fill in the subnet table listing the decimal value of all available subnets, the first and the last usable host address, and the broadcast address. Repeat until all addresses are listed. Note, you may not need to use all rows. So the 0, subnet 0 is 192.168.100.0, and the first usable host address is same 192.168.100 and .1. The first usable host is 1 and the last is 30. The broadcast address is 31 and the first subnet address is 32. So broadcast address plus 1 is 32 and the first is 33 and the last is 62. So basically in the last usable host address is the first subnet address 32 is plus by 30, like in this, equals last usable host address. So the broadcast address is here is 63, here is 64 and 65. 64 plus 30 means 94 equals 94, 95, and then 96, 97. 96 plus 30 is 126. 127, 128, 129, and 158, 158, and 159, 160, 161. So 160 plus 30 is 190, 190, 191, 192, 193, and 192 plus 30 is 222. 222, 223, 224, 225, and 225 plus 30 is 254. Here is 255. So here it is. The end of the mask is 255. Step 2. Assign the subnets to the network shown in the topology. A. Assign subnet 0 to the LAN connected to the gigabit Ethernet 0/0 interface of R1 or router 1. So subnet 0 here, field here 192.168.100.0, and assign subnet 1 to the LAN connected to the gigabit Ethernet 0/1 interface of R1. Subnet 1 here, so 192.168.100.32. Assign subnet 2 to the LAN connected to the gigabit Ethernet 0/0 interface of R2. Subnet 2 here is 192.168.100.64, and subnet 3 to the LAN connected to the gigabit Ethernet 0/1 interface of R2. Subnet 3 is 192.168.100.96. And assign subnet 4 to the one linked between R1 to R2. So the subnet 4 is here 192.168.100.128. So we moving on to the step 3. Document the addressing scheme. Fill in the addressing table using the following guidelines. A. Assign the first usable IP addresses to R1 for the 2 LAN links and the 1 link. Okay, the first usable host address, copy, paste, and the first subnet, copy, paste, and here is the one. So we use subnet 4 for the one link. So here the first subnet, copy, paste, and B. Assign the first usable IP addresses to R2 for the LAN links. Assign the last usable IP address for the one links. So the first usable IP address to R2. So here's copy, paste, copy, paste, and assign the last usable IP address for the one link. So the one link using the fourth subnet, the last 158. Sorry. Copy, paste. Okay. And next, assign the second usable IP address to switches. So we copy and we +1. Same thing. Sorry. 34 and yeah, 130 and sorry, it's 65 to 66 and 97 to 98. Yeah. And the last thing, assign the last usable IP address to the host. The last usable IP address. Here 30 and 62 94, sorry, and 126, like this. And for the subnet mask is all the same thing in here, to 55.255.255.224. Copy, paste, paste, paste. And for the default gateway, in the router there's no gateway. Same thing, no gateway, no gateway. Because it's the router. And for the switch 1, it's from the R1. So here, copy, paste. The switch 2 from the R1, copy, paste. The switch 3 from the router 2, copy, paste. The switch 4 from the router 2, here. And the PC1 is from the switch 1, here. PC2 from the switch 2. PC3 from the switch 3. Here. And PC4 from the switch 4. Yeah, we've done that. Part 2. Assign IP addresses to network devices and verify connectivity. Most of the IP addressing is already configured on this network. Implement the following steps to complete the addressing configuration. Step 1. Configure IP addressing on R1 LAN interface. So R1 CLI enable configuration interface gigabit 0/0 IP address R1 router 1 here 0/0 copy paste and the subnet mask paste and gigabit interface gigabit 0/0 and 0/1 IP address here, copy, paste, and the subnet mask, paste. Okay, we're done, and we go to configure IP addressing on switch 3 including the default gateway. Okay, to switch 3, enable configuration, interface v1, IP address in switch 3, the IP address, copy, paste the subnet mask, and then an IP default gateway, the default gateway, okay, and exit. Okay, we're done, and configure IP address on PC4 including the default gateway. The PC4, stop, IP address. So configure PC4. Yeah, the IP address is this 126. The subnet mask, we change it, and the default gateway is this. Okay, here we can see that all the devices are connected, and the last steps is verify connectivity. You can only verify connectivity from R1, S3, and PC4. However, you should be able to ping every IP address list in the addressing table. So we're pinging from the PC4, command prompt, router 1, we try to ping 192.168.100.1. Yeah, it connected, and we ping again to switch 3, 168.100.66. Something went wrong, request timeout. Yeah, but it connect. We try to ping once again, 192.168.100.66. Yeah, it connect. Yeah, and after that, here's the suggesting score rubric. We can see in this, it's completion 30 out of 30, check result, assessment item, and all is checked. Then we finish the lessons here. Thank you.